In this video, we'll be talking about simple interest. Our learning outcomes are to compute simple interest and future value, compute principal, rate, or time, compute interest using the banker's rule, and then compute the true rate for a discounted loan. So the topic of the next two sections is of interest to anyone who plans to buy a house or a car, or if you have a credit card, or if you invest money, or you have a savings account. Pretty much everyone, right? We all do these things at some point. So this interesting topic is interest, which is a description of how fees are calculated when money is borrowed and how your money grows when you save. So interest, let's define our term here. Interest is a fee paid for the use of money. For example, if you borrow money from a bank to buy a car, of course you have to pay them back the money that you borrowed, but you also have to pay an additional amount, which is the interest for the privilege of using the bank's money. On the other hand, if you deposit money in a savings account, the bank will pay you interest for saving money, since it will be using your money to provide loans, mortgages, etc. to people who are borrowing money. The stated rate of interest is generally given as a yearly percentage of the amount borrowed or deposited. There are two kinds of interest. Simple interest is the first type. Is a one-time percent of an amount of money. The other kind is compound interest. Compound interest. Compound interest is a percentage of an original amount as well as a percentage of the new amount, including previously calculated interest. Compound interest will be the topic of the next video. For this one, we're focusing on simple interest. In order to compute simple interest, we will need three pieces of information. We need to know the principal, the rate, and the time. Let's define those terms. Okay, so interest. Okay, which in our equation, we use I to represent interest. This is the fee charged for the use of money. The principal, which we represent using P, a capital P in our equation. This is the amount of money borrowed or placed into a savings account. The rate, sometimes also called just the interest rate, it's the rate, is the percent of the principal paid for having money loaned or earned for investing money. Unless otherwise indicated otherwise, rates are given as a percent for 1 year. When doing calculations, we'll always write R, the rate, in decimal form. We use a lowercase r to represent the rate in our equation. Time, okay, or sometimes called term, is the length of time that the money is being borrowed or invested. When the rate is given as a percent per year, the time has to be written in years, and that's the most common case. And then the future value which we use the capital letter A to represent this, is the amount of the loan or investment plus the interest paid or earned. Okay? Let's look at an example where we develop a formula for simple interest. Let's say that an account is opened with a deposit of $500 and earns 4% per year in simple interest. That means that after the end of the first year, 4% of the current value will be added to the account. How much interest will be earned? Let's do that right here. Okay, this is pretty straightforward. It's just 4% of 500, right? 4% is the original amount. So it's, say, 4% of $500. And we calculate that in the following way. We take 4% in decimal form, which is 0.04. We multiply that by 500. And the result there is $20. Okay, how about part B here? If that much interest is earned in 1 year, how much would be earned in 5 years? What about in some generic T years? Okay, let's take a look at this. This is kind of common sense as well. If $20 is earned in 1 year, then the amount earned in 5 years would be 5 times that much, right? So in 5 years, it would be 5 times $20. Okay, which is $100. Okay. Using this same line of reasoning, it doesn't matter what the number of years is. You always multiply 20 by the number of years, right? So in T years, it would be T times $20. Or we could just write that as 20 times T, okay? That's the amount of dollars earned. All right, part C. Use parts A and B to write a formula for finding the amount of simple interest earned on an account with a principal value P, interest rate R, and time T. Okay. So in part A, we multiplied the interest rate in decimal form by the principal amount. In part B, we multiplied that amount by the number of years. So overall, we get the product of principal, interest rate, and number of years. So our equation will use I to represent interest. We just multiply the principal times the interest rate times the amount of time. Okay? So here's our formula down here. Formulas for computing simple interest and future value. The interest is simply the principal multiplied by the rate multiplied by the time. I equals PRT. We call that the simple interest formula. The future value would be the principal plus any interest. So we would just take the principal, P plus I, or we could say P plus PRT, because that's what I is, right, given by that the simple interest formula. And then you could factor out a P. And so we end up with this formula right here for future value. Okay, let's look at some examples. Example 2, computing simple interest and future value. Okay. Find the simple interest and future value of a loan of $3,600 for 3 years at a rate of 8% per year. First, we want to change the rate to a decimal and then substitute into the simple interest formula. So the rate is 8%, and in decimal form, that would be 0.08. So my simple interest formula is I equals P times R times T. My principal is the amount of the loan, which is the $3,600. R is the interest rate in decimal form, which is 0.08. And then T is the time, right? So it says we want a loan for 3 years. We'd plug in 3 for t. Use your calculator to work that out. You should end up with 864. 864. Let me try that again. Write that a little better. All right. What happened there? Did not intend for that to happen, sorry. 864. There we go, it's a little better. All right. So that's the interest. The interest on the loan is $864. To find the future value, we take the principal and then we add the interest. Right? So the future value, A, is equal to the principal plus the interest. Okay. So that would be equal to $3,600 plus the interest of $864, or $4,464. So $4,464, that represents the total amount of money to be paid back. Because you have to pay back the loan, which is the $3,600. That's the money that was actually borrowed, plus the interest. So those two together is $4,464. Note that if we hadn't specifically been asked to find the interest, we could have found the future value in one step. We could have used this version of the future value formula, right, and just done it in one step. We plug in the principal, which is 3,600, plug in 0.08 for R, and 3 for T. If you work that out, you'll get the same result, $4,464. Okay. Since rates are typically given in terms of percent per year, when the time of a loan or investment is given in months, we need to divide the time by 12 to convert to years. In general, you want to express your time in the equation in units of years. Okay. So let's take a look at example 3. To meet payroll during a down period, United Ceramics Incorporated needed to borrow $2,000 at 4% simple interest for 3 months. Find the interest. All right, let's come down here. So we will still use the simple interest formula. I equals P R T. The principal is the amount borrowed, which is $2,000. The interest rate is 4%. In decimal form, that is 0.04. That's an annual rate. Because it's an annual interest rate, the time has to be given in units of years. In the problem, it's given in months. But we do know there are 12 months in a year. So if we have 3 months, we can convert that into years by dividing that by 12. Okay. So if you use your calculator and work this out, you'll get $20 as the amount of interest. $20. Okay. Often, a simple interest loan is paid off in monthly installments. To find the monthly payment, divide the future value of the loan by the number of months in the term of the loan. Let's take a look at an example of that. Admiral Chauffeur Services borrowed $600 at 9% simple interest I think my Yeah, that is, the editing got messed up, but it's not 112 years. It should be 1.5 years, for 1.5 years. To repair a limousine. Find the interest, future value, and monthly payment. All right. So step one, let's find the interest. Okay, let's come down here. We'll do our solution down here. Find interest. And that would just be using the simple interest formula. Okay. The principal is $600. The interest rate is 9% in decimal form. That's 0.09. Time has to be in years. But it already is. It says 1.5 years. We just plug that in. 1.5, probably the easiest way to plug that in is as a decimal. That's 1.5 years. Okay. If you multiply these together, you're going to get $81 in interest. Okay, the next step is to find the future value. Find future value. All right, the future value is the principal plus the interest. Principal is $600. My pen is kind of messing up on me again here. $600. The interest is $81. So if you add those together, you get $681. All right. And then the last step is to find the monthly payment. And we do that by dividing the future value of the loan by the number of months. Okay, find monthly payment. Okay, so we have 1.5 years. We want to convert that into months. Well, we know that a full year is 12 months. A half year is 6 months. So combine those together, we get 18 months. So we have $681, and we're paying that back over an 18-month period. So we have to divide this amount evenly into 18 months, right? So we do that by taking, we'll just say M represents the monthly payment, 681, and we divide that by 18 to get the monthly payment, which ends up being about $37.83. Okay. Clean this up a little bit. M equals, that's better. All right. So far we've used the simple interest formula really just to find the interest. But you can also use that formula to find the principal or the rate. Right? Basically, the formula gives a relationship between four quantities: the interest, the principal, the rate, and the time. If you know any three of those, you can find the last one using this formula. So let's look at an example where we find the principal. Philips Health and Beauty Spa is replacing one of its workstations. The interest on a loan secured by the spa was $93.50. The money was borrowed at 5.5% simple interest for 2 years. Find the principal. So let's write down what we know. We know the interest, all right? That was $93.50. We'll say $93.50, okay? We know the interest rate. That was 5.5%. I'm going to write that down in decimal form, 0.055. And we know the time. Time is given as 2 years. So now in my simple interest formula, I know I know R, and T. P is the unknown quantity. That's what we want to solve for. So let's plug in what we know. 93.50 equals P times 0.055. T equals 2, okay? Yeah, so then I solve for P by really dividing both sides by the product of 0.055 and 2, right? So I'd end up with P equals 93.50 divided by 0.055 times 2. And if you use a calculator to work that out, you would get $850. $850. So the amount of the loan was $850. Let's take a look at example 6 here. Computing the interest rate. It says R&S Furnace Company invested $15,250 for 10 years and received $9,150 in simple interest. What was the rate that the investment paid? So again, let's write down what we know. Well, we know the principal, which was $15,250. Okay. We know the amount of time. The time was 10 years. And we know the amount of interest. That was $9,150. What we don't know is the rate. So let's plug the information that we do know into the simple interest formula, and then we can solve for the rate. So I is 9,150. That is equal to P, 15,250, times R, that's what we don't know, times 10. Okay? So if I solve this for R, I'm going to get R is equal to 9,150 over the product of 15,250 times 10. Pop that into your calculator and you would get 0.06. And we could put that in percentage form as 6%. So the interest paid on the investment was 6%, 6% interest rate. 7, this one involves finding the term or the time of the loan. Judy and Laura borrowed $4,500 at 8 3/4% to put in a hot tub. They had to pay $2,756.25 in interest. Find the term of the loan and the monthly payment. Okay, so let's write down what we know. We know that P is the principal, and this is equal to $4,500. R is the interest rate. It says 8 3/4%. That would be the same as 8.75%. I will put that in decimal form as 0.0875. And then we're given the amount of interest as well. We're given I. I is equal to $2,756.25. So my simple interest formula, I equals PRT. Let's plug in the known values. I is 2,756.25. Okay, P is 4,500. R is 0.0875. T is what's unknown. If I solve for T, I will get 2,756.25 divided by the product of 4,500 times 0.0875. If I work that out on a calculator, I would get 7. And this is 7 years. The term of the loan was 7 years. And it says to find the monthly payment. So to do that, we'll need to know the term of the loan in months. Well, there are 12 months in a year. So 7 times 12 is equal to 84 months. So the total amount paid is the principal plus the interest, the future value. That's the principal, which was 4,500, plus the interest, which was $2,756.25. Altogether, that is $7,256.25. So the monthly payment, which we'll call M, is found by taking the future value, which was $7,256.25, dividing that by the number of months. Divide that by 84 months. And that equals about $86.38 as the monthly payment. All right, let's introduce a new rule here. It's called the banker's rule. Simple interest for short-term loans is sometimes computed in days. For example, the term of a loan might be 90 days. In this case, in the formula, we typically want to have units of years. There are 365 days in a year. Unless it's a leap year, then it's 366, right? So generally, we would convert days to years by dividing by 365. However, many lending institutions use what is called the banker's rule. Banker's rule. The banker's rule treats every month like it has 30 days. So it uses 360 days in a year. They claim that computations are easier to do. When a lending institution uses 360 days instead of 365, how does that affect the amount of interest? Well, let's check it out. For example, on a $5,000 loan at 8% for 90 days, the interest would be, using the simple interest formula, right? $5,000 is the principal, times the interest rate in decimal form, 0.08, and then using the standard conversion, 90 over 365 to convert into years. That works out to be $98.63. Using the banker's rule, the only difference is we would divide by 360 instead of 365. But the interest comes out to be slightly higher, $100 instead of $98.63. So the banker's rule actually results in more interest, not a lot more, a little bit more. Of course, if you're dealing with, much larger loans, that can end up being a significant. So we can see why this is called the banker's rule and not the customer's rule, right? Because it actually ends up giving more money to the lending institution. But regardless of how you feel about it, it is a rule that many lending institutions use. So let's look at an example using the banker's rule. Find the simple interest on a $1,800 loan at 6% for 120 days. Use the banker's rule. So the principal of our loan here is $1,800. The interest rate in decimal form is 0.06. And time in years, using the banker's rule, we will take the 120 days and we will divide that by 360. Okay. So if I plug that into the simple interest formula, I would get 1,800 times 0.06 times 120 over 360. And that works out to be $36 of interest. Okay, discounted loans. Sometimes the interest on a loan is paid up front by deducting the amount of the interest from the amount the bank gives you. This type of loan is called a discounted loan. The interest that is deducted from the amount you receive is called the discount. Example 9 illustrates how this works. So we want to find the true rate of a discounted loan. So let's say that a student obtained a 2-year, $4,000 loan for college tuition. The rate was 9% simple interest, and the loan was a discounted loan. So we want to find the discount, find the amount of money the student received, find the true interest rate, and discuss whether this seems like a deceptive practice. Okay, let's take these one at a time. Start with A. The discount is the total interest for the loan. So let's identify the principal. That's the $4,000. Okay. The interest rate, it says that's 9%, 0.09. The time, it says it's a 2-year loan, so time is T. So using the simple interest formula, this is equal to 4,000 times 0.09 times 2. And that works out to be $720. Okay, B. Find the amount of money the student received. So the student received $4,000 minus the interest, minus 720. So that means the student received $3,280. Okay. C, find the true interest rate. The true interest rate is calculated by finding the rate on a $3,280 loan with $720 in interest. So again, we're going to use the simple interest formula. The amount of interest is $720. The principal here is the amount of money the student received, which was $3,280. Okay. R is the true interest rate, which we're trying to find. The term of the loan is 2 years. Okay. So R is equal to 720 divided by the product of 3,280 and 2. Okay. And that works out to be about 0.1098, or as a percentage, about 10.98%. So the true interest rate is about 10.98%. Okay, D. Is this a deceptive practice? Yes, it is. Why is it? Right, because you're being quoted a loan at 9%, but the actual percent you're paying is almost 11%, right? The actual amount because of the discount taken into effect. So, so you need to read the terms carefully, right? So if it's advertised as a discounted loan, that means you're probably going to end up paying a higher actual rate than the quoted rate. So keep that in mind. Okay, so that wraps up this video. In the next video, we'll be talking about compound interest and how that works. So thank you for watching.